to this side of the room. We'll start here in the front.
I'm Phillip Sloss. I think for Charlie, just to try and get a little bit more color on what you saw yesterday with the hydrogen concentrations in the umbilical cavity. Because when we first saw it, we first saw the report, you were up to about 55% or somewhere in that neighborhood. Did you see elevated hydrogen concentration throughout fast fill, or did you see a change near the point where you tripped the limit? And then were you seeing any difference between the flows through the fill and drain line and the bleed line, either in that space of time, or again, you talked about getting into pressurization at T-minus 6 minutes. I assume you get into drain back at that point through the bleed line. Is that what is that what possibly tripped the limit during terminal count?
So let me start with when we saw the leaks. Let me start there. So, what we have learned during the Artemis tanking campaign is that this interface is sensitive to flow rates and pressures. We learned that during Artemis 1, and we saw the same thing. Yesterday. It was when we went to fast fill. We were in slow fill. We were within our limits and within our bands. It was when we transitioned to fast fill that we began to see the limits creeping up, or the concentrations within the cavity creeping up. And we did, was it a steady rate? I mean, it increased. We got up to, probably 12, 14%. And then when we got close to the 16%, that's when we did stop flow and revert, and decided to invoke our procedure for letting that interface warm up and then retrying it again. During Artemis 1, we found that sometimes that was very successful. I mean, that's a pressure-assisted seal, so sometimes letting it warm up and then putting some more pressure across it, you'll see the seal improve. And so that was the goal yesterday. When we tried it the second time, the performance was pretty similar. We have the ability, and what we do in that case is that we are actually pressurizing in the storage area, in the sphere itself, and we're kind of using that pressure to, hydrogen's light, and so you put some pressure in the system and kind of push it, as we say, push it up the hill. And so we started out with a lower pressure, but as we put additional pressure and got back closer to our fast fill rates, we started to see the leak. And so it was, I would say, in and around the 12 to, when we got up to 16%, we would take action. We saw that through the 3 different contingencies, but we were able to manage it. We would manage it with the pressure, get back within your leak rate in the cavity, or get close to it. And so that's how we managed to get all the way to replenish. In terms of when we saw the spike in the leak, it was in terminal count. It was as we began to pressurize the tank, and whether that came from through the 8-inch or the 4-inch bleed, we really need to get into the plate and take a look, and we'll know more, in a few days when we get in there. So it'd be hard to say at this point. Again, the team's going through the data, so if you ask me tomorrow, I might have a better answer. But right now, I'd tell you that based on the timing, it looked like in real time that it was likely through the 8-inch. Could have been the 4, though. So we'll take a look at all that and see what was going on there. But it did go up, and it went up very quickly, and so we knew that we had something there we didn't understand. That's why the operator immediately gave a cutoff, and we got into safing.
Okay, we'll go to Irene.